you for joining me. Welcome to TJ's Maths Clinic. Let's consider this question from Elective Mathematics, that is further mathematics from Wassce 2025 for private candidate. This is January, February. With us here is question 7. Let's consider this question 7. Question 7 reads, a uniform beam XY of length 12 meter and mass 10 kg is supported at 2 points P and Q. Bodies of masses 50 kg and W kg are placed at X and Y respectively. If XP is 2 meter, that's length XP, this sign means length. Length XP is 2 meter, length QY is 3 meter, and the reaction at P is 514.29 Newton. We are asked to calculate, correct to the nearest whole number, the value of W and the reaction at Q. First thing to do is to identify this question is from which topic. Of course, this is from applied mechanics under static equilibrium. Let's look at the concept. This is under moments. We have uniform beam. We have to interpret the drawing. We have to draw the our meter rule to put all this information on it. Let's look at how we can handle this. Let me do the rough sketch here. Then after that, I'll clean the question and do the drawing in a bigger way for proper understanding. Thank you for joining me. Let's say let's write down the solution. Let's say we have our meter rule of this nature, where we have Y and X. At the center of gravity here, we have the weight 10 Newton. We have 10 kg rather. We have to convert this 10 kg to Newton. That's we multiply it by 10. That will be 100 Newton. This is the center of gravity. Very important. We are told that the body of masses 50 kg and W kg are placed at X and Y. At X here, we have 50 kg. Convert that 50 kg to Newton. That's multiplied by 10. Because we are asked to take G to be 10 meter per second square. Okay? So 50 times 10, that will be 500 Newton. Then at Y here, we have W. Let me leave it in kg. Whatever the value of W, I have to convert it to Newton. Very important. Another way, the length of the meter rule is 12 meters. But we are told that XP is 2 meters. Then the support is X and the support is P and Q. Suppose we have the support here, that's the pivot here. From X to, then this will be P, and this is 2 meters. Then we have another pivot here, which is the support P, a Q now, that is 3 meters from Y. Okay? The entire meter rule is 12. So if you have removed from this center to X is 6, from this center to Y is 6. If you have removed 2, we'll be left with 4 here. So the length here is 4 meters. And the leftover length here is 3 meters. Very important. Okay? Where the reaction at P is given as 5 point. The reaction here, which is the upward force now, is 514.29 Newton. Then the reaction at Q, we are asked to find that, let it be R2. So we are looking for two unknown. The weight W and the reaction R2 to the nearest whole number. This is the interpretation of this question. So we are through with the question. We are asked to calculate correct to the nearest whole number, the reaction at Q as well as the weight W. Let's remove the question and redraw again to get the proper understanding of the question. Let me clean here. Then let me enlarge this. We have the meter rule this way, let me draw it a little bit. When we have y and x, the weight at this x is 500 Newton. Then we have the center of gravity here, CG, which is given as 100 Newton. And we have a support here at P, which is 2 meters from X. Then the remaining length here is nothing but 4 meters. We have another support here, which is Q. We have the reaction at Q as R2. The length here is 3 meters. The length here as well is 3 meters. Then we have the weight W kg at Y. Very important, okay? This is how the drawing is going to be. Then we have reaction at P as 514.29 Newton. So this is the enlargement of this drawing. I think we're through with our drawing. Yes, we're through. So let's use this to find the reaction R2 and W. So let me clean this so that we can have space. Very important, okay? For this meter rule to be in equilibrium, the sum of upward forces must be equals to the sum of the downward forces. That's one of the conditions for a system to be in a state of equilibrium. The upward forces must be equals to the downward forces. That's number one condition. Condition number two, sum of clockwise moment must be equals to sum of anti-clockwise moment. That's number two. And moment is nothing but force times the perpendicular distance from where we are taking that moment. That's from the point of action. Very important concept. So before we can find the weight W and the reaction R2, we have to look at the forces that are acting in anti-clockwise and clockwise direction. Like, let's say we want to eliminate this reaction at P. To eliminate this reaction at P, we have to take the moment at P to find R2. That's number one. But before we do that, we can say sum of upward forces. Sum of upward forces is equals to sum of what? Sum of downward forces. So it means let's sum the upward forces. That will be 514.29 plus the reaction R2 will be equals to, we sum the downward forces. That will be 500 plus 100 Newton plus W. This, of course, will lead to simultaneous equation because we are looking for two unknown, R2 and the weight W. Let's rearrange this and add. We can say R2 minus W will be equals to, we add this, that is 600 minus 514.29. This will lead to equation 1, of course. 600 minus 514.29, what are we going to get? 85.71. So R2 minus W will be 85.71. This will now be our equation 1. So it means the upward forces, the sum of upward forces is equals to the sum of downward forces. Okay? Again, sum of clockwise moment, sum of clockwise moment, sum of clockwise moment will be equals to sum of anti-clockwise moment. Very important. So let's now look at the forces that are acting in clockwise direction. That's taking moment at P now. Taking moment at P. If you are taking moment at P, what will be the forces that will be acting in clockwise direction and anti-clockwise direction? Let me remove this part to to show you the forces. If we are taking moment at this point here, this W will act in clockwise direction. It will tilt this direction because this is force multiplied by the distance from the point of what? The perpendicular distance from the point of action here. What again can we see? This 100 Newton will act in clockwise direction as well. This is the secret to moment. Again, what about this 500 Newton? This is 500 Newton and we are going this way. So the force will tilt this one. We have the force this way multiplied by the perpendicular distance from the point of action. So this 500 Newton will act in anti-clockwise direction. What about this reaction R2? R2 again will act in anti-clockwise direction as well. Very important. So we have two forces acting in clockwise direction and two forces acting in anti-clockwise direction. Of course, this reaction at P will go because we are trying to eliminate. To find R2, we have to eliminate the reaction at P. Very important. So let's look at it. Our clockwise moment now will be W times the perpendicular distance from where we are taking the moment. We are taking the moment, so we have to sum all the distance here. That will be 4 plus 3 plus 3. Of course, that will be 10 plus 100 Newton from the point of action or from where we are taking the moment. The distance, perpendicular distance is 4. That will be 100 times 4. This will be the sum of clockwise moment. Will be equals to sum of anti-clockwise moments. First, that will be 500 Newton multiplied by the distance from where we are taking the moment, which is 2 meters now, which is multiplied by 2 plus the reaction R2 now. That will be the reaction R2 times the perpendicular distance from where we are taking the moment. We sum this distance here. That will be 4 plus 3. Of course, it will be 7. So, of course, this will lead to equation 2. Let's multiply 10 times W. 10W plus 4 times 100, that will be 40, will be equals to 5 times 500 times 2, that will be 1000 plus 7 R2. Let's rearrange. This will be 10W minus 7R will be equals to 1000. Here is 1000. 1000 minus 400. 10W minus 7R2 will be equals to 1000 minus 400, of course, will be 600. This will now be our equation 2. So to find R2 and W, we have to solve these two systems of equation simultaneously. Very important. So we can remove the drawing, we are through. So this is the beauty of moment. Just know that moment is nothing but force times the perpendicular distance. So let's remove the drawing and pick our two equations to solve them simultaneously. Equation 1, R2 minus W is 85.71. Equation 2, let me bring R here. That's 7R2 plus 10W equals to 600. Let's say we want to eliminate W to find R2. This is equation 1, multiply this by 10. This is equation 2, multiply this, let's say, by 1. That's the coefficient of W in equation 1. 10 times R, that will be 10R2 minus 10W will be equals to, multiply this by 10, that will be 857.1 minus 1 times that will be 7R2 minus 10W will be equals to minus 600. So let's add. We are trying to eliminate W, so we minus so that W will go. Okay, this will go. Then 10R minus 7R, that will be 3R. 3R2 will be equals to 857.1 minus 600, that will be plus 600. Very important. That will be 1457.1. So we divide both sides by 3 to find R2. Divided by 3, that will be 485.7 Newton. This will be the reaction at Q. We are through with R2. Very important and interesting. I hope we are together. And then last but not the least is to find our W. Let's use, yes, to find our W. To find W, we can say put R2 equals to 485.7 into, let's say, equation 1. Let's say we are using equation 1. And our equation 1 is nothing but R2 minus W equal 85.71. Anywhere we see R, we put 485.7 minus W equal 85.71. Very important. Let's switch this. Let's bring the W here and take this back, since this is less than this. So we have 485.75 minus 85.71 will be equals to W. Let's subtract minus 85.71. What do we have? W now is nothing but 399.99 kg. Mind you, we did not convert our W, it was in kg. So this is in kg. Now we have to convert it to Newton. And when we are converting from kg to Newton, we multiply it by 10. Very important. We multiply it by 10. So W now will be 399.99 multiplied by 10. That will be 9399.9 Newton. This will be our W, okay, which is in Newton now. So, since it is in kg, we can't leave our answer in kg. We have to convert it to Newton. But since we have converted other this thing in Newton, Wkg, if we are to convert to Newton, it means there is 1 kg here. That will be 100. That will be 10 W now. That will be 10 W. So let's use 10 W instead of using it in kg, so that whenever we see this W, it will be 10 Newton. That will be the force. But let's leave it this way. The answer will be 3,999.9 Newton. So this will be the solution to this question. Thank you for watching. Please do share this to your learned colleagues, and don't forget to subscribe to TJ's Maths Clinic for more interesting videos. You can follow me on TikTok, Instagram, and Facebook. See you in my next video.